So this question's about chlorine radicals, free radical substitution. Write two equations show how chlorine radicals react with the ozone molecules in the upper atmosphere. So the first equation is that Cl dot, which must have been made already, probably by Cl2 chlorine in the presence of ultraviolet light in the initiation step, making two Cl dots, and then this is a propagation step. So the Cl dot is then reacting with the ozone. Ozone's O3. The only thing it can turn into is O2. There's only two forms of oxygen, O3 and O2. So O3 must turn into O2. And then what have you got left? You've got a dot, you've got Cl, and you've got one of the O's left over to keep three O's on either side. The dot can go anywhere around this radical. Then this radical is going to react again. It's very reactive, a radical, and it's going to react again with more O3, and it's going to make two lots of O2 in a Cl dot. So it's going to react again, react with O3. The only thing that it can turn into is O2. 4 oxygens on the left hand side, so you can balance that by 2 O2s, and then you've got a Cl dot. And then this is a chain reaction in which it carries on and on and on and on and on, because the Cl dot is a catalyst, it's reformed. Chloropentafluoroethane is CFC. Draw its displayed formula. So what have you got? Chloro, Cl, penta is 5 fluoros. You've got 1 Cl and 5 Fs around ethane 2 carbons. So you can draw them any way you want. It's got to be displayed, so you've got to show the bonds. That must be done. It must be a displayed formula showing the bonds. 5 Fs and a Cl. They can go anywhere. 1,1,1 trichloroethane CF3CH3 is one of the molecules being used as a refrigerant. Explain why 1,1,1 trifluoroethane does not lead to the depletion of ozone in the upper atmosphere. It's because it's got no Cl's in it. It doesn't contain chlorine. One of the steps in the synthesis of 1,1,1 trifluoroethane is the reaction of 1-difluoroethane CHF2 CH3 with fluorine in a free radical substitution reaction. Write two equations that represent the propagation steps in the conversion of this into this. Well, if you've got fluorine in a free radical, then you've got F2 in ultraviolet light making two F dots. So this time you're using F dots rather than Cl dots. But it's the same principle then. You've got turning CHF2CH3, CHF2CH3 and an F dot. It always makes HF, or if you're using Cl dot, it always makes HCl. It makes HF or HCl depending on whether you're using F dot or Cl dot. But that's always made, and therefore you can work out what's left. Well, I've got 2 carbons, and I've got 2 Fs, and I've lost one of the H's. Now, where does the H get lost from? That's the question. Does the H get lost from here, or does the H get lost from one of these 3? So what's eventually going to happen is, where the H gets lost from, that's lost a bond. And if it's lost a bond, the bond is broken. And that bond is broken, and the electron, one of the electrons in the pair, has come back onto the carbon. So in other words, that carbon with the dot shows that it's missing a bond. That carbon has got 2 Fs, 2 bonds to an F, 1 to the C, so it's got 2 Fs and 1 to the C, and the dot represents the missing bond, the electron that was in that bond. So that's showing that that carbon is missing a bond, and an F's going to go onto there in a minute. So an F is going to join onto there and make CF, not 2 but F3, and that's why I know that that dot is on that carbon, because that is going to be replaced, that H is going to get replaced by an F. So that H must be lost so it can get replaced by an F, and the dot is on that carbon there. What's going to happen next? This is going to react with fluorine then. So this reacts with F2. Okay, so this reacts with F2, always makes an F dot again because this is a catalyst in the chain reaction, and therefore we make CF3CH3 as it says in the question. A refrigerator contains 1.41 kilograms of this chemical. Calculate the number of molecules in the refrigerator. Give your answer the appropriate number of significant figures. So why are we given mass? Why are we given a formula? We must be asked to work out the number of moles. So moles is this in grams. Moles is mass in grams divided by relative formula mass. So this in grams, a large unit number like a kilogram going into a smaller unit number like a gram. So you multiply by 1,000. So 1.41 multiplied by 1,000 is 1,410. You can work out with a periodic table that an F is a 19, the Cl is a 12 in terms of mass numbers, and H is a 1. And so if you add all of those together, the MR is 84. You've got 16.8 moles of this 1,1,1 trifluoroethane. Now, the number of moles multiplied by Avogadro's number gives you the number of particles. So number of moles, 16.8 multiplied by 6.022 times 10 to the power of 23 will tell you the number of molecules in that sample. To 3 significant figures. Why to 3 significant figures? Because some of the other values, like 1.41 kilograms, are to 3 significant figures. So 3 significant figures is needed because one of the other values is to 3 significant figures. There are growing concerns about 1,1,1 trifluoroethane as a refrigerant. Give one reason why the bonds in the molecules, such as carbon dioxide, absorb infrared radiation. Well, the reason that bonds absorb infrared radiation is that they stretch or bend. Vibrate, stretch or bend.